Sweets in this question are very odd looking sweets. We've got a cuboid one with jagged pointy edges, which I'm sure won't be nice in the mouth, and a cylinder sweet. We've got a bit of information given on the diagram and a bit of additional information here. The same volume as a cuboid. The cylinder has the same volume as a cuboid. So it starts off, it is lovely to have a nice easy question. The volume of the cuboid, well, that's just going to be those three lengths multiplied together and plugged into your calculator. Nice and easy. It gets you exactly 1.32. No need to round or anything like that. Moving on then, so our cylinder, we don't know the radius, it's what we're being asked for. We do know the height and we do know the volume, so we'll have to set up an equation with volume, height and that. So our cylinder is essentially a prism, with the bottom being its cross section, so we need the area of a circle multiplied by the height. So that means the volume, which would be pi r squared, that's cross section volume, we multiply by h as well, and we know that's going to be 1.32. I'll just substitute in what h is, which is 0.8. So pi r squared 0.8 equals 1.32. So I'm just going to divide by 0.8, which gets us 1.65. So pi r squared is equal to 1.65. So to finish this question off, I'm going to have to find r as the subjective formula. So r squared is going to be 1.65 over pi, not the actual answer because we want to know r, so I'm going to have to square root that whole lot, 1.65 over pi, which doesn't give us an exact answer. It gives us 0.725 centimetres. That's 3 significant figures. Always worth just having a look back up to the top. Does that sound about right? Does that radius look like it's just a little bit shorter than the height? Yeah, sure, why not? It's not to scale, but if it were a 700, I'd know something would have gone wrong. So, part 3 then. The difference between the surface areas of these two sweets. So, I now have all the dimensions of both of them, so it's fairly straightforward. I've got to work out the surface area of the cuboid and the surface area of the cylinder, and then find the difference in them. Now, I think the surface area of the cuboid is quite easy, so I'm just going to pause this and do it quickly now. Okay, hopefully that makes sense to you. We've got 3 faces, 1, 2, 3, but 2 versions of each of them, and then summing those together gets a surface area of 7.46. So now taking this and looking at the cylinder. Now a cylinder has 2 parts to it. It's got the pi r squared, 2 of those. So that's the top and bottom of our cylinder. Just quickly scrolling up to have a look. That's these 2 circles, the 2 at the top. The area of circles pi r squared. Obviously we've got 2 of them, the top and the bottom. The other bit's that curved surface area. You have to remember this. Or just think about it. It is the 2 pi r, which is the circumference, and then times the h. It's essentially a rectangle, which is that bit, and 2 circles. 2 circles. So the rectangle has a height like that and a width like that. So if I substitute in what I've got with my value of r from here, and being very exact, we should use that from memory, not actually 0.725, or it'll end up off. I'm going to plug that into my calculator now and see what we get. Okay, so that for my cylinder, oops, wrong button. For my cylinder surface area, gives me 6.94. So not exactly, but 3 significant figures. So to finish that off, I need to do the 2 of them. 7.46 subtract 6.94, giving me an answer of 0.517 centimetres squared to 3 significant figures.